Topic 2 in Algebra 2 is all about quadratics. So everything that we're going to graph is a parabola. So today we're going to focus on the vertex form of a parabola. And to be able to do that, we need to remember our transformations. So adding or subtracting a number to the end moves the graph up and down. By adding or subtracting a number inside the parentheses, it moves it left and right, and it's the opposite of what you think. The minus outside is a reflection and turns it upside down. If you put a number in front of the function that's greater than 1, it's a vertical stretch and it'll make it thinner. And if it's a fraction in front of it, it is going to make, between 0 and 1, it's going to make the graph fatter. Okay, so the vertex form of a parabola is y equals a times x minus h squared plus k. In this equation, the vertex can be found by looking at the point hk. Now notice this says minus h and this is plus h, so the h is the opposite, but k is going to match exactly. The axis of symmetry is going to be the vertical line that if you fold the graph in half, everything is going to match up. So the axis of symmetry is going to be x equals whatever the x-coordinate of the vertex is, which in this case is h. The minimum or maximum, we're going to have to look at each graph to decide if it's a minimum or maximum, but it's always going to be at point k, which is the y-coordinate of the vertex. Now just to make sure we're all on the same page, if this is your parabola, this point right here is your vertex. All right, so the first one that we are going to look at is the parent function. This is your basic parabola, and we've studied this before. There are no transformations on it because this is the original. So in the original, we're going to start with the vertex at 0, 0. Now, instead of just memorizing the points, I want you to learn a pattern this time. So to get the points, you're going to go right and left 1 and up 1 because 1 squared is 1. You're going to go right and left 2 and up 4 because 2 squared is 4. We're not going to plot the points, but if you went right and left 3, you'd go up 9 because 3 squared is 9. If you went right and left 4, you'd go up 16 because 4 squared is 16. In this parent function, there's nothing subtracted in the parentheses and there's nothing added or subtracted outside of it, so our vertex is 0, 0. The axis of symmetry is x equals the x-coordinate of the vertex, which is 0. Now we're not going to graph it, but if we did, this is where the axis of symmetry would be. If I'm looking at this vertex right here, it's the bottom point on my graph, so it is the minimum value, and the minimum value is always the y-coordinate, which is also 0. The domain, as we go from left to right, it's always going to get wider, so the domain is negative infinity to infinity. But the range is the y's, and we have to go from the bottom up, so as we go the bottom up, nothing, nothing, nothing. It starts at 0, and it's a bracket because that point is included, and it goes up to infinity. For all the problems we're going to do today, the domain is always going to be negative infinity to infinity. There's nothing to remember or to learn there. Okay, if we look at number 2. On number 2, if we state the transformations, the minus 4 tells me I'm going to go right 4 because it's inside the parentheses, the opposite of what we think. And the positive 1 says that we're going to go up 1. My vertex, it's the opposite of what's in the parentheses, so positive 4, and then whatever number is added on, which is 1. The axis of symmetry is always x equals the x-coordinate, which is 4. So if I had to graph that, the vertex is 4, 1. My points from the vertex, I'm going to go left and right 1 and up 1 because 1 squared is 1, left and right 2, and up 4 because 2 squared is 4. And there is my parabola. This vertex right here, because it's at the bottom, is a minimum, and it's a minimum at the y-coordinate, which is 1. All these have a domain from a negative infinity to infinity, and the range, you have nothing up until you get to 1, and then it goes on to infinity. On the next one, the plus 5 tells me I'm going to go left 5. The minus 6 outside tells me I'm going to go down 6. So I'm going to go left 5 and down 6 and plot my point. My vertex is the opposite, which is negative 5. And then the same as this one, minus 6. The axis symmetry is x equals negative 5. So if I'm looking at my vertex, negative 5, 6, from there I'm going to go right and left 1 and up 1, right and left 2, and up 4. And there is my graph. This vertex right here is the bottom point, so it is a minimum, and it's a minimum at the y-coordinate, which is -6. My domain is -infinity to infinity. My range starts at -6 and goes on up to infinity. On number 4, the negative is a reflection, so it's going to open down. And the +3 tells me I'm going to go up 3. My vertex, there's nothing or added or subtracted in the parentheses, so my x is 0, but this gives me my y, which is +3. The axis of symmetry is x equals the x-coordinate, which is 0. My vertex is 0, 3. But this time, because of the reflection, this one is going to open down. So instead of going right and left 1 and up 1, I'm going to go right and left 1 and down 1, and then right and left 2 and down 4. And here is my parabola. This point right here is the tallest point, so now it's not a minimum, it's a maximum, and it's a maximum of the y-coordinate at 3. All of these domains are -infinity to infinity, but the range, all these y values at the bottom are included, so it starts at -infinity and stops at 3. On number 5, that 2 is going to be a vertical stretch. It's going to pull it closer to the y-axis. Okay, and the -4 tells me I'm going to go down 4. The vertex, nothing is added or subtracted to the x in the parentheses, so it's 0, and then the y is -4. My axis of symmetry is x equals the x-coordinate, which is 0. So I start at 0, -4. Now normally I go right and left 1 and up 1, but now I have to go right and left 1, and 1 doubled is 2, so I'm going to go up 2. And then I'm going to go right and left 2, and instead of going up 4, I need to go up 4 doubled, which is 8, and I'm doubling it because of this number in front. And when I do this, it's going to stretch my graph out and make it thinner and pull it closer to the x-axis. This right here is my minimum, and my minimum is always at the y-coordinate, which is -4. All these have a domain of -infinity to infinity. This one, the range starts at -4 and it ends in infinity. On number 6, the transformation, the 1/2 is a vertical shrink. The -3 tells me I'm going to go right 3. And the +1 tells me I'm going to go up 1. So the vertex, the opposite of what's in the parentheses, so +3, and then what's added on, which is 1. Axis of symmetry, x equals the x-coordinate, which is 3. So I'm going to start at 3, 1. But normally I go right and left 1 and up 1, but now I need to go up half of a 1, which is just a half. Okay, then normally I go over 2 and up 4, but I have to go half of 4, so I'm just going to go up 2. Oops. Oops, I didn't go up 2. Okay, so I'm going to go over 2 and up 2 from the vertex, and now it's wider, it's a little bit fatter, and it's pulling it closer to the x-axis. This is a minimum, and it's a minimum at 1. The domain is -infinity to infinity, and the range is 1 to infinity. On number 7, the negative is a reflection. The 2 is a vertical stretch. The +3 is left 3, and the +5 is up 5. The vertex is the opposite of what's in the parentheses, so it's -3, 5. The axis of symmetry is x equals -3. So I'm going to start at -3, 5. But this time, I normally go over and down, or over and up, so now I have to go over and down, but it's over and down doubled. So over 1 and down 2, because 1 doubled is 2. And then over 2 and down 8, because 4 doubled is 8, so it's thinner and more stretched out. This vertex is up top, so it is a maximum, and it's a maximum at the y value. The domain is always negative infinity to infinity, and the range, it starts at the bottom but stops at 5. Okay, on this last one, we have a 1/4 would be a vertical shrink, so it's going to get fatter. The 5 tells me I'm going to go left 5, and the -6 tells me I'm going to go down 6. My vertex, the opposite of what's in the parentheses, so -5, and then the number added on, so -6. My axis of symmetry is x equals the x coordinate, which is -5. So I'm going to start at -5, -6, which is right here. Now normally I go over 1, up 1, but 1/4 of 1 is just 1/4. And then normally I go over 2 and up 4, but 1/4 of 4 is just 1. And so my graph is like this, and it's much wider. This is a minimum, and it's a minimum at the y-coordinate of -6. All these, this is a domain of negative infinity to infinity, and the range is -6 to infinity. On this one, the axis of symmetry, now we're going to do all this without graphing. So the vertex we know is 5, 6. The axis of symmetry is x equals 6. This one is going to be opening up, so it's got to be a minimum at the y-coordinate. All these have the same domain. The range, you'd have nothing until you got to 6, and then it would go to infinity. On number 2, the vertex would be 3, 7, because the -2 does not change the vertex. The axis of symmetry is x equals 3. But this time, because it's negative, it's opening down, so it's going to be a maximum at the y-coordinate. The domains are all going to be the same, but the range is going to go to negative infinity, and it will stop at 7. Okay, for the last two, we want to write them in vertex form, which is y equals a times x minus h squared plus k. Okay? Well, if we have a vertex, this is our h, this is our k, and a point can help us find x and y, but what we're missing is that a, so we're going to plug it in. So we're going to have y, which is -1, equals a times x, which is -2, minus h, which is 1, squared, plus k, which is -4. Now inside the parentheses, we have to do first, -2 minus 1 is -3, but -3 squared is +9. So I have 9a minus 4. To finish solving, I'm going to add 4 to both sides. So I get 3 equals 9a. I divide by 9, so a is 1/3. That leaves my equation to be y equals 1/3 times x minus h, which we know is 1, squared, times, plus or minus k, so minus 4. There's my equation. If I do that over here, this is my h, this is my k, but my y-intercept is not an ordered pair, so I'm going to rewrite it as 0, -1. So this is my x, this is my y. So when I plug it in, I have -1 equals a times x, 0, minus h, -2, squared, plus k, which is 3. Well, minus a negative is plus a positive. 0 minus 2, or excuse me, 0 plus 2 is 2. 2 squared is 4, so this would be 4a plus 3. So to solve, I'm going to subtract 3 from both sides. So I have -4 equals 4a. Divide by 4, a equals -1. And now I can write my equation, which would be y equals -1 times x minus h, which is -2, so plus 2 squared, plus k, which is 3. That's it.